Tyrannosaurids were a family of theropods that were the dominant carnivores in North America and Asia in the late Cretaceous period, approximately 100 to 65 million years ago, the most famous of which is, of course, Tyrannosaurus rex. T-Rex could weigh up to 10,000 kilograms, putting it as one of the largest terrestrial carnivores ever known. Like all tyrannosaurids, T-Rex stood on two legs, had a massive skull, and relatively tiny yet powerful forearms. Tyrannosaurus is about the same size as an African elephant, the largest living land animal today. The closest modern-day equivalent to the carnivorous T-Rex is the Siberian tiger, which weighs only 300 kilograms. Being such unique and intriguing creatures, we naturally want to learn everything about the massive tyrannical lizard king, with particular emphasis on its eating habits. But despite half a century's research, Tyrannosaurus's eating habits are not very well recorded. Tyrannosaurus's eating habits have been a recent topic of dispute in the paleontological community. It is being disputed whether T-Rex was a predator, a scavenger, or both, with no side having any particular conclusive evidence. But here's an intriguing question. Could they possibly be cannibals? In a 2010 study of Maastrichtian dinosaurs, scientists found a theropod pedal phalanx that had large teeth marks. That is, they found large bite marks on the toe bone of a large two-legged carnivorous dinosaur that lived in the Maastrichtian, that is, 72 to 66 million years ago. Since it was the largest carnivore we have found in the Maastrichtian, this finding suggests that Tyrannosaurus made these bite marks. Upon finding the specimen, the group looked for more specimens. The group examined fossils in 8 different museums all across America and Canada, and found 17 specimens identified as having teeth marks from T-Rex, which are shown in the following chart. First, observe the marks on herbivores. Here we see various specimens bearing marks of T-Rex bites. Let us take a closer look. Notice the deep U and V-shaped gouges and shallower scores. These are clear signs of T-Rex's trademark puncture and pull strategy. Shown here are the marks found on the bones of Chasmosaurus and Hydrosauridae. Make note of the patterns in the bite marks. Got it? Let's compare the bite marks made on the herbivore's bones to this set of bones. Look clear that the bite marks made on the herbivorous dinosaur bones are identical to the marks found on these bones. Let's examine Figure A. Figure A is identified as a theropod by the ginglymus articular surfaces and deep collateral ligament pits. We refer to it as a Tyrannosaurus on the basis of its large size, robust construction, and provenance. Comparisons show that the bone is a left pedal phalanx from a large adult animal. The largest tooth mark is 25 millimeters long and 7 millimeters wide. Figure B is a second set of Tyrannosaurus bite marks that were found on a partial skeleton of Tyrannosaurus. On the left foot, it's pedal phalanx number 2, and it bears many gouges on all sides. The largest tooth mark is approximately 70 millimeters long and 3.5 millimeters wide. Again, this bone came from a large adult. The third example comes from an associated skeleton of a large adult Tyrannosaurus. The left humerus, shown in Figure 2C, bears a series of scores. They are up to 36 millimeters long and 3 millimeters wide. In Figure D, we see a fourth Tyrannosaurus specimen bearing conspecific bite marks. The specimen consists of an isolated right metatarsal 3 missing the proximal half of the shaft. It is identified as Tyrannosaurus by its large size, triangular shaft, and the splint-like proximal end. It bears 2 scores on the medial surface. The larger is 44 millimeters by 4 millimeters. The distal end of the bone is approximately 11 centimeters across. Again, the bone comes from a large adult. We have now evaluated the evidence and made keen observations. But what does it mean? In fact, the evidence speaks volumes. First of all, it easily tells us that these marks were made by a theropod. The teeth marks closely match the tapered U or V shape of theropodal teeth. The marks are relatively narrow and deep, and were made by tightly spaced teeth, very similar to the teeth of theropods. Could it be anything else besides theropods? Could anything else have made these marks? Clearly, it couldn't. It couldn't be crocodilians. Their conical, unserrated teeth produce much shallower marks. Some lizards do have xiphodont teeth, which produce marks similar to those made by theropods, but are very rarely this big. Mammal bite marks would be far smaller and would have closely spaced tooth marks. As you can see, these do not. Insects would not have made these because their scratches would be very small and would produce tunnels rather than scratches. Furthermore, excavation tools would have shattered the bone. So we can clearly see that these must have been made by only a theropod. But wait, there's more. By looking at just the sheer size of all of these bite marks, it is clear that this could only have been made by the largest of theropods. And who are the largest of the theropods? The tyrannosaurids. And in case we need reminding, who is the king of these tyrannosaurids? That would of course be Tyrannosaurus rex. These marks are clearly made from feeding rather than combat. By looking at Exhibit 2C, we see that the bone has been bitten many times, on the toe. It is highly unlikely that the T-Rex would have had the chance to repeatedly bite a larger animal on a single toe. Furthermore, fighting animals attack the head, neck, and flanks rather than the toe. The absence of healing on these bones also mean that the animal was dead when the T-Rex had finally gotten its chance with it. We can in fact go even farther and say that cannibalism must have been pretty common in T-Rex. Despite our small sample size of 17 cases, out of those 17 we found 4 clear signs of cannibalism in T-Rex. Let's understand the many factors needed to prove cannibalism. 1. The act of eating and feeding on carcasses, such as ingesting bones, dragging carcasses, etc., destroys evidence. 2. The animals had to have left tooth marks on the carcass bones. 3. Many T-Rex diagrams are mounted, which doesn't allow for further examination. Although the scientists tried to examine as many T-Rex bones as possible, looking for such traces as cannibalism, they could not examine every single T-Rex bone in all the museums. So given these factors, it is surprising that they found even one clear case of cannibalism. So from this, we can say that there must be far more examples of cannibalism out there, but have possibly been damaged or erased beyond recognition. We can see that T-Rex was definitely a cannibal, concluding that it was an opportunistic and indiscriminate scavenger, feeding on herbivores and its own species alike. We can see its scavenging behavior through the location of its teeth marks, always on the feet, toes, and arms of the carcass. It would only find these parts appetizing if most of the meaty carcass has already been eaten by the carcass's original killer. In conclusion, cannibalistic behavior was indubitably present in T-Rex. The marks we have observed are clear signs of Tyrannosaurus's feeding habits. More specifically, that T-Rex was an opportunistic scavenger, feeding on herbivores and its own species alike. Provided that cannibalism has a very low preservation potential, we can confidently go even further and assert that cannibalistic behavior must have been relatively common in T-Rex. However, the pervasiveness of this behavior must be conclusively proved and no doubt will be a source of further investigations. But one thing is clear from our evidence: T-Rex was indeed a cannibal.